Hello everyone. Today we will be talking about a problem from thermodynamics. Before we get into the problem, let's define thermodynamics first. So, thermodynamics is a Greek word which means flow of heat in physical and chemical reactions. It deals with energy changes in physical and chemical processes. Okay, so the problem says that aluminum metal can be recycled from scrap metal by melting the metal to evaporate impurities. A. Calculate the amount of heat needed to purify 1 mole of aluminum originally at 298 Kelvin by melting it. The melting point of aluminum is 933 Kelvin. The molar heat capacity of aluminum is 24 joules per mole Kelvin, and the heat of fusion of aluminum is 10.7 kilojoules per mole. So, before we get into the problem, we will be using a formula called Q equals mc delta T. And Q, obviously, it is the heat lost or gained by the solution in the reaction. And M is the mass of the solution. And C, it is the specific heat capacity of the solution. And when the concentration is low, the heat capacity of the solution is usually 4.184 joules per gram Kelvin. And lastly, delta T means the final temperature, which is Tf, minus the initial temperature. Okay, now we have the formula, so we can just plug in numbers. So M is 1 mole, and the heat capacity, as we know, is here, 24 joules per mole Kelvin, and the delta T is 933 minus 298. So Q equals 1.00 times 24 joules per mole Kelvin times 635 Kelvin. So we will get a number in joules. Okay, so in order to do the next question, B, we will convert joules into kilojoules. Okay, so this number is in kilojoules, and we are not done. Okay, so this is only the heat that needed to raise temp by 635 Kelvin, and the heat to melt once at melting point is another part of this question. So we will use 1 mole of aluminum times here, the heat of fusion of aluminum. And then we can get this number. Okay, so it is also in joules, so we will convert it and then plug the 15 joules here we got. So the total is 26 kilojoules. So this is the answer for question A. Okay, so let's get into the second question. It says the equation for the overall process of extracting aluminum from aluminum oxide is shown below, which requires less energy: recycling existing aluminum or extracting aluminum from aluminum oxide. Justify your answer with a calculation. So this means that the heat necessary for 1 mole of aluminum oxide, you can get 2 mole of aluminum and 1.5 mole of molecular oxide. So in other words, if you put in this much heat into aluminum oxide, you can get these products. Okay, so since we have 2 aluminum here, we will just need to use 1675 kilojoules per mole divided by 2, and then that's the heat of aluminum. So it is 833.5 kilojoules. Okay, so let's say the answer: to extract 1 mole of aluminum from aluminum oxide requires 873.5 kilojoules. And to recycle 1 mole of aluminum requires the number we just got, 26 kilojoules, which is much less energy. Okay, then we are done.